Hello, I'm Alex, CEO of Mining Math, and this video is just to respond to a set of questions, very hard and tough and interesting questions that I have received over here. And I decide to go through those questions as quickly as possible, but try to respond properly to them. So I hope this is just an informal video. But I hope this is useful for you to understand what is SimSched about and where we're going to. So here questions about block model. Do you need a rectangular region of defined blocks or only blocks containing estimated values provided false for undefined blocks? So SimSched needs a block model, a regular block model. Doesn't need to, it cannot be rectangular because you need to take out the air blocks. So that you don't need to import a surface to say, okay, here is the topography and below is the rock. But you do need to remove those air blocks so that SimSched understands what is below. Although if you import, if there is absence of some blocks in between the model, SimSched understands that those are blocks with default values. It just needs to have a block above that was imported. So we assume if there is a block above somewhere, so everything below that is a rock. Okay. What's the maximum number of blocks processed to date? Around 1 year ago, we are in August 2016. Around 1 year ago, we have tested a model with 240 million blocks and around 10 or 20 mining periods, if I'm not wrong. And it took around 3 weeks to run. Of course, it's a huge model. It's just to test the limits of SimSched. And this was an older version. So we want to perform this test again as soon as we finish some bug corrections that we are dealing with now. Okay. Can I compute values inside SimSched? No, not yet, but this is not a big deal. It's more related to an interface. As you plug values and it calculates the economics automatically. So we should do this in the future. And as we include SimSched as a plugin of other products, most of the mining software already have tools for value calculation. So this may become easier as time passes. Okay. Can you handle multiple indicator kriging and other nonlinear block distribution models? Well, we can handle. SimSched doesn't care about what are the grades and things like that in the model. What it is mostly based on economics. So if you have models, you calculate what is the consequence that come here. You have the destination, so you import. Okay, if the block goes to this processing route, it's going to have this economic value, which is a field in the imported block model. You can have multiple processing routes, multiple waste dumps, and each one with a different economic value. So just place the values and in the imported block model according to your estimation method or simulation. So can you manage simulated models, multiple realizations? Yes, and it's ready. We're not working on it. SimSched, Sim is about simulations, although we're not advertising this a lot at this beginning because we believe the direct block scheduling part is the biggest shift we're doing in mine planning. But we also do deal with multiple scenarios. And those multiple scenarios could be simulations of grades, could be simulations of rock types, could be economics, different, for example, you can apply different revenue factors and have multiple columns of economic values in the input block model. and you can ask SimSched to find one single shadow that respects all scenarios simultaneously. And you can combine all those sources of uncertainty, and SimSched simply needs one to be informed in the input file that you are referring to a set of scenarios, not only one scenario. So this is already working, and we deal with the robust way of dealing with uncertainties. Well, this is a huge topic. We can discuss further if you want. Processing time, how long to reach 100% optimality? This is on the website. This is around 1 hour. Okay, just say numbers because it changes according to the parameters also, not only the size of the model, which is around 3 million blocks, but also the parameters that we use, and it changes as we improve the software. Sometimes we can make it more efficient, sometimes we need to improve some other things, and it's a bit slower, but in average I would say 1 hour. Have you tested the performance of a superblocked model to compare in various scales? Not with this model, but we have this model with 240 million blocks. It is, we have this big one, we have the same one with 30 million blocks, and the same one with around 10 or 5, I don't remember, million blocks. And actually it's not just superblocked, it's actually the geologists did the work with the full block model with smaller blocks. In one case, in another case was a gold mine, but it is a private, it's from a company, we cannot share. But we have this, and we intend to go more in deep testing once we finish solving the non-issues that we're dealing with now. Computer type, no, nothing extraordinary. For this very complex case that I mentioned, more than 200 million blocks, we used a computer with 32 gigabytes. But for most of RAM and i7 processor from Intel, so it's no big deal. For common, our developers usually work with 8 gigabyte computers. We have some servers with 16 gigabytes, and that's enough for running all the cases we need to. Okay. Agglomeration used, we see on the video on the website is kind of out to date because we keep improving the software, but we don't record videos every time. So I just got one result that we got this last week, and in the future we should be recording a video explaining specifically this case. But just to let you know, this is also McGlaughlin. And you see the periods over here. If you compare to what is on the website, you see this is getting much better than before. And of course it's not perfect, but it's just to show that we are capable of developing better and better algorithms that will deliver realistic solutions. Okay, and something very interesting in this case is that we have forced a certain situation. You may have noticed we have a field over here for surface mining limits. You can use forced mining to force something to happen, or restrict mining to not allow the mine to go on a certain region, on a certain range of periods. We can have multiple ranges here, 1 to 5 and 6 to the end, and so on. And I'll just show the result here. We have used this surface to constrain the optimization, and we said that I don't want the mine to go below this surface until period 4. So this is what happened. You see all the mine happen in this region up to period 4, and then just, you see, just after period 4 that we start mining other regions, which is this dark blue here, that if I can take out. So you see, just in period 5 it started going outside this region. This is one very interesting tool. As you go doing direct block scheduling, you can test for example, environmental issues, and you can also force some regions to be depleted. So in our example, we're going to force this area to be mined first, and we'll test a second waste dump that will be used here after, I don't know, period 3 maybe, and we'll show that this is using this kind of tools. You can do a lot of interesting exercises, and you notice that you're not constrained by pushbacks because you're running directly from the block model. So you can find very different solutions. You can test something happening here and then after test something the other side. So I'll just go through the periods just to let you see the result. I think this is okay. You have an overview. Okay, let's come back to the questions. So yes, we don't have to predefine the agglomerations of blocks. Okay, during the optimization, SimSched chooses solutions that respect certain parameters to test. So it just ignores solutions that we understand are not feasible. So that's why I usually say that if we have more things to get better in terms of the algorithm, what we need to do is to tell the mathematical model that this kind of solution is not interesting for us, is unfeasible. So don't consider this kind of solution and test other solutions. So we're going to improve over time. This is kind of implicit modeling that you don't have the best solution in the first version of the software, but as you keep receiving feedback and tests and so on, you keep improving the geometries and the parameters, and things tend to get better over time. Okay. Next, blending. If it's currently supported? Not yet, but we are working. We have started working, and soon we are going to release a version of the PD optimizer with blending. So this doesn't exist, and we are going to offer this for free, the PD optimization. And many people ask why you offer this for free. Well, simply because we believe direct block scheduling is the future. So we give for free. If you just want to do PD optimization, well, go ahead and do it. Okay, but if you really want your mine to succeed and have best results and have tests over time with net present values and this kind of evaluation, so you should consider doing direct block scheduling. But if you just need a PD optimization or something like this, go ahead. This will happen very soon. Slope definitions, slope field in the model to define slopes in each block, but allowed typically direction dependent. How to accommodate this within each block? SimSched has slopes for each block, and that's it. The current version has this. You can import, could be a default value, or you can import in your block model and have here one slope, different slope for each block. But we don't deal with directions yet. Although this is for the algorithm, it doesn't make any difference because we're just comparing elevations of the surface and on all the directions. So for now, if we have two points to compare, we take what's the slope angle in this region, what's the slope angle in this region, and if they are different, we take the average of them to consider the slope of those 2 points. But of course, we already have to check all around in the 8 different directions in X, Y, and the diagonals. And so we just need to have kind of an interface to inform the variations that we could have. The user could, for example, import 8 different slope angles for each block, which would mean all the 8 possible directions. So it's totally doable, but it's just a matter of pipeline and priorities. We haven't developed this yet. So slope definitions by region, rock type, water table. We just don't have an interface for doing this automatically, but the user can do whatever he wants in the input file. The user could put one slope angle for each block using all these complex relationships as he wants. Okay, so can SimSched analyze complex multipits? I'll talk about this first part first. So multipits, although the algorithm doesn't care much, it won't be a big deal in terms of algorithms to have multiple bits working at the same time. The algorithm would be the same, just handling different surfaces at the same time. But in terms of interface, this has a lot of work to be done. So if you have a way to put those models together in one single block model, SimSched will handle as one single surface that, well, that will manage the shadow over there. But we're not ready to import multiple block models and handle those at the same time. We'll get there at some point. And multiple process destinations that may require cross-ship from one another. Multiple destinations is possible. So you have here destinations. You can put as many destinations as you want. And for each block, you're going to inform. If I take the block and send to this destination, this is the value. So what are you asking here? You can do it, no problem. Just set up the economic values accordingly for doing that. So this is possible as long as you put all the models in the same model. Can SimSched incorporate chained processes, roasting followed by milling and so on? Not completely. Indeed, this is also not ready and easy on the interface. What you would need to do to help you doing that is modeling all the possible paths for a block. So you could have one process that means if the block goes from one process and then the other process and then the other process, then this is the meaning of this first process. And then you can have another route in the second one and third one. So you can list all the possible paths that the block can go, and you play with the constraints. So you say, okay, for this route, I'll have this amount of material, for the other route, the other amount of material. And of course, this is not enough for you to automatically control, like how much, for example, if the first three routes are related to materials going through one of those processes in real life, so I would need a production constraint for the set of the first three processes, although I could have 10 processes in this context. But we don't have it yet. The only total field we have is total for everything. But you can notice here that it's not a matter of changing the algorithm. We could include total production limits for a group of processes, of destinations, okay? And this would facilitate this kind of control. We already have this total implemented, so it would be just a matter of adapting this to have multiple totals like this. Can split and recombine tonnages on strings. So we would need to go more in deep the same discussion that I have mentioned here. We can get there at some point. Next, throughput models, tons per hour relationship by attribute. What we usually mention is that we are working on general constraints, blending and other general constraints at the same time, because they are kind of similar. One is related to summing values, the other is related to the average of values. So what is going to be possible very soon is, for example, you can mention in a block model that block with those characteristics, the lithiotypes and everything, if it goes to a certain process, it's going to be take 8 hours, for example, to pass that material through that process. So you can put this information into all blocks, and if I send that block to that destination, I can account sum all the time for all the blocks in that period and put a constraint saying, okay, but I have just, I don't know, 100,000 hours in this period to process materials. So I need to have blocks that if I feed those blocks into that process, I'm going to be able to process all of them. So you can place many constraints like this, and this would help you to guarantee that your mine plan are not going to produce more material than you can handle on your processing chain, whatever it is. Okay, this will be ready very soon in the next version of SimSched. Same as above, but related to blended material. Blend to maximize throughput. Well, this is a complex conceptual discussion. What SimSched is going to do is, you have in a block, what's the throughput if you send that block to the process. So if you have recovery curves and any curves you need for throughputs and so on, you should be relating to one block, as if I put that block alone over there. We know this is a higher variability than if you place materials in stockpiles and then take the stockpile and place there. But the other way around, which is considering that in 1 year, I'm going to put all the material from the mine in one big stockpile, and this material will be perfectly homogenized to send to the process. This is too optimistic, okay? So, and there is nothing in between both. As long as if you're working just with optimization, you would need to work with simulations of process of the stockpile reclaiming and so on. So in the context that we believe that it makes more sense to keep this variability. We assume that, well, I'm processing one block at a time, and this is worse than if I put things in the same stockpile and try to blend a little bit to homogenize. Okay, we understand these differences. This will happen once we won't have this, at least we're not planning to have, but it's doable if we're convinced that this is important. Value model, multi-element, commodities, melting. Well, everything is possible because SimSched just it doesn't have a calculator that's ready. What SimSched needs is the economic values for each block if I send the block to a given destination. So you can put whatever calculation you want to do, whatever, varying by bench and varying by whatever you have. And also you can have multiple economic models and import all the economic models at the same time. And you can do two different things. You can like run one with this economic value, and then I run again with another case, and then I run again with another case. This is one way of testing multiple scenarios. Another way is to inform SimSched. I'm not going into details here, but you can inform in the input file that, okay, I have 10 scenarios here, but I want to run all at the same time and return just one shadow that is robust to all at the same time. This is also feasible to do, including with economic models. Stockpiles, multiple stockpiles by grade. This is feasible currently if you can deceive SimSched by, for each processing route you put here, you have an option of a stockpile. You see here, you have a limit. So if you have only one processing route, but you want to have 3 different stockpiles with some criteria, what you could do is to manipulate the inputs to separate those blocks into like 3 different bins with the characteristics that you want to, and then you know that what you want is that the sum of those 3 categories of blocks have this certain proportion. So you could come here and inform, okay, process 1, 2, 3, and in this example 20 million tons, you could say, okay, I want 5 million tons of this kind of material, 5 million of the other kind, and 10 million of the other kind of material, and SimSched will will treat as 3 different processing routes, but you know that in reality, for each processing route, you're going to have one stockpile associated to that processing route, and you know that the sum of all of them mean one single processing route. So it's a way to deceive SimSched, but it's possible to do what is being asked here. And to constrain a stockpile by period. We can constrain, but not by period yet. This is another thing that's not a big deal, because well, it's not a big deal in the current situation of SimSched. We can place a limit here. This is for the total of the life of mine for that stockpile, but you could also include, this is not difficult to do. You could also deceive SimSched, like including 2 processing routes, and say, okay, this processing route in my constraint here, from period 1 to the end, I could include 2 intervals and say, for example, from period 1 to period 5, I'm going to use this processing route with 20 million tons. But let's suppose I have process 2 here. I could say, here, this process is 0, and this other one is going to be 0 here and 20 million here. So in the end, you know that the process 1 and process 2 are the same process, but you could include one stockpile for this one with a limit for this 5 years, and another stockpile for this one. Of course, it's a way to deceive, and it's not perfect. It's not going to send material from one stockpile to the other, but is a way to do with the current version. The visualization currently through SGEMS, yes, but SimSched is a plugin, and it has APIs, and we could easily plug into other platforms. We hope to have more agreements with mining software companies that want to have this kind of technology within their products, and we're open to this kind of collaboration. We're not here to fight and to compete. We're ready to work together. Outputs, annual bench plans. No bench plans, because we're not scheduling benches. SimSched is direct block scheduler, so we work block by block. We put blocks together to make reasonable solutions, so we don't have a list of benches. And actually, SimSched doesn't deliver solutions like, oh, this bench is going to be mined at 40% at this year and 60% at the other year, and this means 40% of each block in that bench and 60% of each block. And this is, we know this is not real. SimSched assumes this is an output, a CSV file after it runs. You have a folder like this with the surfaces and the Excel file. And one of the CSV files is this one. We have the indexes of the blocks, the coordinates, if the blocks mined or not, and the period which is mined, the period which is processed, as if the blocks is stockpiled. For example, here it's mined in 12 and processed in 15. The destination, and the rest is just a copy from the input file, except by the value, which is only the value of the destination chosen, okay? Because the input file has many values, this is the chosen one. So I think with this I answer also this question. And well, as I said, this block is going to be mined entirely in period 12. Okay, there's no possibility of SimSched mining partially blocks. We believe it's unreal, and we're not implementing this way. And end of period surfaces, yes. If you see on the folder, we have one file for each period, and this is a grid file. You see X, Y, Z is a set of points that you can import in any software. And you can see in SGEMS is also exported automatically. Now place here, you see period 4 is this set of points. Of course, it's SGEMS doesn't have a tool to triangulate, to draw control lines yet. I hope it happens in the future, but any software that you import those points, you can have a nice visualization. So this is period 14. You see it's taking all the material from the mine. So this is it. You can take the solution, open in Excel, like here. You can manipulate elevations of the solution. You can come back to SimSched and place that solution here to force something, to restrict something. So just working with SimSched and Excel in this kind of files, you can do a lot of things if you don't like the solution you're seeing here. For example, I don't like this mine over here. I want to not to mine these periods. These are the last periods. I'm going to force this to be depleted in an early period. So this is an exercise you're going to do soon to show you. And I think that's it for those questions. Sorry for the long video, but if you have more tough questions like this, I'm happy to receive, and from time to time I'm going to record some more complex explanations like this, and I hope this is useful for all of you. Bye bye.